Hello and welcome to Quiz Questions. So this is number one. First problem we got wrong was number one. So what you have to do is you have to find the area under these two curves, add them up, and also don't forget to add 0.5 because that was the starting position. The mistake we made here was that we didn't really know and understand what was going on before we got into this. But when we find the area under these two curves, since this one's positive, this one would be negative since it's under the curve. So this one, the area for that one, it'd be three wide plus. Let me write it down. The area for a curve is half base times height. The base here would be about 1.5, half height 3 minus, so we can put this in brackets. Over here would be half 1, and then down there it would be 2. And this comes to be about 1.25. But we need to forget to add the initial height, so that's plus 0.5, so it'll be 1.75, unlike the 1.25 that we got previously. So moving on to the second problem we got wrong, number 2. We have a rock that is thrown horizontally off a cliff that is 20 meters high. The rock has an initial speed of 10 meters per second, and yeah. Okay, so let's see how we do that one. Oh yeah. So thing we need to know is height, initial speed. Ignore the air resistance because we don't have any. So we have a rock. Let's visualize. 20 meters. Velocity of 10. Okay. So what do we know? Velocity is equal to displacement over time. So that would mean x is equal to velocity times time. Time will be equal to the square root of 2h over g. The h is, sorry, we made a minor mistake. So square root of 220 over 10, which would equal to 40 over 10 square root, which is just 4 square root, which is 2. Plug that one back into the original one, so we have velocity of 10 times a 2, which is equal to 20, which, like Mr. McClure said, is ironic because 20. So yeah, that's how you solve that one. Let's see, next one we missed was was it 3? Yeah, 3, which basically asked if an object is moving in that direction and an object's being sprung up, where's the object going to land? Very important to note, Newton's first law. Even though it's moving this way, no other force is acting upon this, and Newton's first law says that an object that is in motion will stay in motion. So because there was no like external force acting upon this ball except for the spring, and since it's moving at a constant velocity and nothing else is affecting it, it's still going to go this way, but it's just going to go up and down and stay on the same. As long as this object doesn't accelerate or decelerate and stays at a constant rate, it's going to go up and down. So that's number 3. Number 4, our mistake here was that I remember we put D instead of C. So our reasoning was that since D was on the line, then that would mean it's at the same velocity. But when you think about it, really, all it's saying is when they're at the same rate. So that's kind of an interesting mistake to make, but a learning opportunity. So yeah, just next time I'll look into the lines. So inertia and number 4. Look. Number 6. So number 6 we have this, which is basically the same thing as number 1. What we have to do is find the area under the curve. We didn't do that. We just assumed that the numbers was 10, 10, 10, 10. So it'd be 40. But no, you just you have to find the area under the curve for every graph because it's velocity over time. So we have the base, which is, this is going to be half base times height. So we know the base is 4, and then the height is 40. So that's 4, that's 40. So that's half of 160, which would be 80. Boom, bada bing, bada boom. Mr. Worldwide, Mr. 305. Got it. Now the last question that we have to do is number 8. It says an object undergoes acceleration as it travels in a straight horizontal section of the track. Which of the following graphs could represent the motion? So we look at these 4 graphs. We put C and D. Only C was right because B and D are basically saying the same thing. Let's explain what each of these graphs say. So this is saying that as time passes, the speed's going to increase, which, if you think about it, is just acceleration. So that should have been 1. Number 2 is position over time. The position is constant and changes at the same rate as time. So what does that mean? That means the velocity is constant. So that's VC. Where we know that if the velocity is constant, there is no acceleration because it's just going at a constant rate. This one, position over time squared, position over time, position of seconds over seconds, and we just know, well, that's just acceleration. That's, you could tell. Velocity over time, we know that the velocity doesn't change as time passes, so that's constant velocity, VC. So our mistake here was that we didn't understand what these graphs meant, so we should have just circled C and A. Thank you very much.